Question number 5. This tells us that we have two circles with centers A and B that intersect at x, which is point 1, 7, and y, which is 1, 1. These 2 points of intersection are labeled, and the circle is centered at B, which is point -3, 4. They're telling us another piece of information, that both circles have the same area. So they want to know the area of quadrilateral AXBY. So there's a lot of information here and no picture. What you want to do is draw this out on your XY coordinate plane. So we have circle B is centered at -3, 4. So that's our center of circle B. Then we have point of intersection 1, 7, and 1, 1. So looking at that, we can now figure out our radius of this circle. So this is our x, this is our y value, this is our b value, and A is going to have to be somewhere equidistant over here. So first thing we want to do is figure out A. So we know that the distance from B to this line xy has to be the same distance as A to that line, because we know that the areas of the two circles are equal. So if the x value at B is -3 and the x value over here is +1, that's 4 units away. So therefore we have to go 4 units to the right of line xy to get the x coordinate of A. So since this is 1, we go 1, 2, 3, 4, and that is going to give us point A, which is 5, comma, and it's going to have the same y value as point B, so it's 5, 4. So if you look at this, so what we have going on here is a bit of a parallelogram, and there's 2 ways for us to get the area of a parallelogram. The main formula for area of a parallelogram is base times height, but when you do base times height in a parallelogram, it's most effective when you have one that has at least 2 sides that are either parallel to the x-axis or parallel to the y-axis, because your base is then easy to calculate, and so is your height, because your height always has to be perpendicular to the base. You could also have it like this, where the 2 sides are parallel to the y-axis, and then you would have the same easy time figuring out your base and height. Since this parallelogram is not parallel to either the x-axis or the y-axis, what we want to do is get the area of each of the triangles that make up each side of the parallelogram. So if we got the area of x, y, b, and then doubled it, that would give us the area of this entire parallelogram. It's going to be way faster than you figuring out the actual length of xb and the actual length of XA. So looking at this, we automatically know that the distance from x to y is going to be the difference from the y coordinate at x, which is 7, to the y coordinate at y, which is 1. So that's just a distance of 6 units. The distance from B down to the base is going to be the distance of the x value at B, which is -3, to the x value here, which is 1. So going from -3 to 1 is 4 units. So that's going to represent our height. So the area of this triangle XYB is going to be 1/2 times the base, which is 6, times the height, which is 4. So 1/2 times 24 is 12. Now if you know that the area of this triangle is 12, the area of this triangle also has to be 12, so the area of that entire quadrilateral is going to be 24. And that is going to be your answer for question number 5.